In this video, we're going to review some of the characteristics of functions concepts in Skill 1.3. So this is out of the diagnostic, and we have these three functions, f of x, g of x, and h of x, to base our work on. So the very first question on the diagnostic, well, the first question is about a graph. I'm going to return to that in a minute. The second question says evaluate f of 4. If I look at this, the 4 is in the x spot, so I know the x value is 4. I'm going to come up here and use my f function. So I'm going to substitute in 4 in place of x. And then I'm going to simplify. 1/2 of 4 is 2. 2 plus 7 equals 9. So f of 4 equals 9. The second question that I have says solve h of x equals 7. So in this case, I have the whole h of x written out like this, and the 7 is, that means the 7 is going to be equal to the whole function, so it's a y value. So I'm going to have 7 equals 5/4 x minus 3. First I'm going to add 3 to both sides, so that gives me 10 equals 5/4 x. Then in order to eliminate this fraction, this 5/4, I'm going to multiply by the reciprocal, which is 4/5. I have a 5 on top and a 5 on the bottom, 5 in the numerator and a 5 in the denominator. That makes a fancy 1. These 4's also make a fancy 1, so I'm left with x. And then if I take this, I'm going to do the 10 divided by 5 part first. 10 divided by 5 is 2, and then 2 times 4 is 8. Notice I would get the same thing if I multiplied across and did 4 times 10 is 40 divided by 5. 40 divided by 5 is 8 as well. So you could get the same answer in a couple different ways. Let me go ahead and erase some of this, if I can. And now we'll continue. So the next question is evaluate g of 2/3. Okay, and again I'm thinking to myself, is 2/3 an x value or a y value? It's in the place of x, so it's an x value. So I'm going to substitute in for x. If I look at evaluating this, I can think to myself this is the same thing as -2/1. -2 times 2, I'm going to multiply the numerators. That's -4. 1 times 3 is 3. So this first part here is -4/3 minus 1/3 is going to give me -5/3. Moving on, we have f of g of -3. This is composition of functions, and remember we're going to have to work from the inside out. So I'm starting with g of -3, and I'm going to do this in stages. So first let me grab, I'm going to do g of -3 in green here. -3 is an x value, so that's -2 times -3 minus 1/3. That's going to give me +6. -2 times -3 is a +6 minus 1/3. If I want to think about this as an improper fraction, the 6 as an improper fraction, I know that 18 divided by 3 is equal to 6. I want my improper fraction to have a 3 in the denominator because I have a 3 in the denominator over here. So that's going to give me 17/3. So far, that is, let me shrink this a little bit. So far that's just the g of -3 part. And I still need to evaluate f of g of -3. So I'm really looking for f of 17 over 3 using the f of x function. That's going to be 1/2 times 17 over 3 plus 7. Multiplying across, multiplying the numerators, I get 17. Multiplying the denominators, I get 6. And I'm needing to add 7 here. So again, I'm trying to think of a way to combine these two numbers. One way that I could do it, because I have a whole number over here, is to think about this improper fraction and figure out what this is as a mixed number. So thinking about 17 over 6 as a mixed number, if I divide 17 by 6, 6 goes into 17 2 times. 2 times 6 is 12. 17 minus 12 is 5. So this is really equal to 2 and 5/6 plus 7. So that's going to be 9 and 5/6. So 9 and 5/6 is equal to f of g of -3. So now taking the eraser, let's get some space here. Start eliminating some things. Okay. The next problem that I have is f of h of x. This is another composition problem, except instead of having a value for x, I just have the whole function h of x substituted into f of x. So I'm going to take my h of x function and I'm going to substitute it in for x in the f of x function. So that's really going to be 1/2 times 5 over 4x minus 3 plus 7. So again, this whole part here is being substituted in for this little x right here. Now if I want to simplify, 1 times 5 is 5, 2 times 4 is 8, so that's 5/8 x, minus -3 times 1/2 is -3 over 2, plus 7. 7 is the same thing as 14 over 2, so I'm going to have 5/8 x minus 3 over 2 plus 14 over 2. And so f of h of x is going to equal, let me shrink this just a little bit more, 5/8 x, and then -3 over 2 plus 14 over 2 equals 11 over 2. All right, one more on this one. So again, I'm going to try and get rid of this. Get some space. Last one, we need to find f inverse of x. Okay, and remember this f with the little -1 that looks like an exponent, we really call that f inverse. And if you remember, inverses, we know a couple things. We know for inverses that the domain and range flip-flop. That's an important relationship for inverse functions, and it also tells us what the first step is. So if the domain and range flip-flop, and I'm finding f inverse, that tells me that the very first step is going to be to flip-flop or reverse my domain and my range. So first I'm going to rewrite this as x equals 1/2 y plus 7. The next thing I'm going to do is get y by itself. So I'm going to subtract 7 from both sides. Moving up here, that gives me x minus 7 equals 1/2 y. To undo multiplying by 1/2, I can multiply times 2. And when I do that, I need to multiply the whole left-hand side by 2, not just the x. So that's going to give me y equals 2x minus 14 if I use the distributive property here. And then the very last step is to rewrite the y as f inverse. So the inverse of the f of x function is 2x minus 14. Now there's only one other thing on this part of the diagnostic to talk about, and that's what makes something a function. So we have this picture here on the diagnostic with a sideways parabola. This one is not a function, and it's not a function because in order for it to be a function, every x value has to be paired with just one y value. If I look at this sideways parabola and I think about these 2 points here, these 2 points are right on top of each other. They would have the same x value, so we can even make something up. This might be 3, 4, and this might be 3, 10. They have the same x value, but they have different y values. In that case, that does not meet the definition of a function. The definition of a function says that for every x, you have just one y value. So this one is not a function. For any representation that you're given, you can really think about this picture and see if it meets the definition. So for example, if I had a random table of values and I had 2, 7, 3, 5, 2, 6, and I needed to tell if this is a function, what I could do is just quickly think about a graph of this. And if I'm thinking about a graph of this, I'd have the point 2, 7, which is somewhere up here, 3, 5, and 2, 6. The 2, 7 and the 2, 6 are going to be right on top of each other. That's going to violate the definition of a function where every x has just one y, so this one would also not be a function.